Hello. Topic of today's presentation is how to get money out of your Istio service mesh observability. And let me start with the question. So can you please raise the hand if you are familiar with Istio or other service mesh? Okay, so quite a few people. And now, maybe if you enjoy working with Istio. So can you please raise a hand again? Not many. That is interesting. Okay, so I'm Marek Śmigielski. Doing this, preparing this presentation, I realized that I have 1 month ago, I just turned exactly 20 years of experience on my contract in IT. So it was quite a nice journey, and hopefully, thanks to Istio as well, this journey is still very exciting. So what to expect from my presentation? First, I would like to show you a little bit what Istio is, at least from my point of view, like that we are more or less on the same page. Second, I would like to dive into observability features of the Istio, so the topic of the presentation. And lastly, I would like to show you how to use this knowledge that you can take it and get it to the your Istio installation, so you will actually enjoy working with Istio afterwards. The disclaimer is that the photos or illustrations are prepared generated by AI, so don't be scared. I would like also if you can give me some feedback later if you like it or not like it, if you think this is the good idea or bad idea. And on the presentation will be the DevOps dollars, so you will know where this value is coming. So, yeah, so starting with Istio. Istio is the networking layer on top of Kubernetes cluster. So that will be a like one sentence introduction. And for the core functionalities of Istio service mesh, let me bring you the load balancing. So it allows you to load balance the traffic between your components, between your microservices. It allows you to do a service discovery also outside of the Kubernetes cluster. So that's like addition to that. It gives you encryption, not by default, but it's really easy to set up the mutual TLS or the traffic encryption between the different components or service mesh and outside world. It gives you traffic management in different forms, in fact. So it gives you a traffic management so you can define the rules to repeat the request if something goes wrong. So this is nice. It's connected to resilience as well. It is also functionality like circuit breaker, timeouts, a lot of different stuff. So it's very good. And then it gives you, of course, some monitoring and tracing capabilities that we will focus this presentation today. So where does this Istio coming from and why it is happening? So maybe some of you remember the backwards when we have the application servers, the monolithic big monolithic applications, and the complexity of the communication was within the monolith, so it was inside. And when we find a good idea to build the microservices, we grew on those monolithic applications. That will be a better word, but the complexity, unfortunately, is still there, and it is between the components communication. So that is why, to leverage or simplify or make this possible to manage this complexity on communication, we have found out that service mesh is a good idea. So we bring the service mesh to the table, and that is why we can have this talk, for example. Some of you might already been scared a little bit, but I don't want you to get back from this presentation with the idea that service mesh is good in every case. So I want to scare you a little bit as well. So it is not good always. So it brings some complexity to your infrastructure. It also brings some overhead in both management and in communication, so it's basically there. The learning curve is something that is, I would say, extraordinary with service mesh, because it's something I didn't have happened to find out elsewhere. So it is quite difficult to learn Istio or service mesh in general. So don't be, if you just need to be persistent in doing that. Operational burden. So sometimes if you know the tools, it helps. If you don't, it will slow you down. And potentially you can be in the situation of the vendor lock-in. So you need to be careful on those things. There are some clear situations when you should avoid using a service mesh. So first is like when you have a simple application. Don't put service mesh there because you will not have any benefits, but you will have only problems with that. If you have limited resources, and the resources here is a time, that is risk budget, reliability budget on your application, so you can have like very little time. Like I would say that also the small team, but it's more like about time, risk, and reliability budget. Don't start with service mesh in those situations because you might be in the bad situation later. In very early stage of development, focus on your applications and don't focus on infrastructure, and the service mesh is a part of infrastructure. Focus on applications, so build application first. Then if you are starting with Istio, consider this twice if it is a good idea, especially if you are low on resources. But if you have like maybe small project, POC, that's the good place to start learning that technology. And some of you might be on the performance critical applications like low latency, intertrading, whatever it is that requires really huge performance. Then Istio might not be a good idea or candidate there. To help you start, because that's the whole introduction on Istio, so I believe that you are not yet ready to install this. This is quite nice tutorial that you can spend a few hours to get the basics and then start playing that yourself. So I would say this is the first place that you will get the value out of this service mesh if you learn it. So that's the very important part. And now on to the observability. So I don't like the observability term myself that much because I think it's a buzzword that it's bumping around our industry. Does not help. But in the case of the Istio, observability is really let's say well presented because it gives you the logs, Istio, it gives you the metrics, monitoring, and it gives you traces as well out of the box that I will show you later. So it's really showing all the observability that we can talk about. So just before we talk about the first thing from the observability, the situation that Istio introduced that we are all aware is that it gives you the proxy layer. So there's an envoy proxy that is added, and all the traffic that is coming out of your pod or into your pod will be proxied by this layer. So maybe I can show you this one. And this layer is a proxy, so there's the different names for it. It's Istio proxy, Istio sidecar, envoy proxy, envoy, so you might find the different names for it, but the purpose is that your traffic will be proxied by this. It is not something that will stop your traffic, but it is something definitely that will adjust your traffic. So on this example, that the proxy is active, so it can detect what kind of traffic is coming through the proxy, and then decide what to do with that. So it can route the traffic. In this case, it will route the traffic to the CNN service, and generic traffic that is not understood with this kind of service will be with the generic outbound service, which is called the pass-through cluster. So this can all happen, and there's really plenty. As we discussed these key functionalities, there's plenty of options that you can do with routing traffic. So understanding that we are on the we are with the proxy layer, so it gives you the logs. It gives you the access logs that come through your cluster into outside. And as you can see, this is the example of the JSON logs, which is quite handy if you parse it with the tools, of course. So it can be also like readable format, but JSON, I would say, better, because then you can use it with the tools that you like. I do the parsing to the tables. It will be two tables. So the first one is just a generic that you can be familiar with the engine or Apache or whatever access logs. fancy that. There are 3 types of requests that are in the columns. So first is the plain HTTP request. That usually it's not the way to go when we talk to the different external endpoints or even without internally. So usually we should use the HTTPS. In this case, the second column is this TCP or TLS. So when we start the transaction, HTTPS transaction from the pod to outside, the Istio layer, the request will not be able to trace this traffic. So you will not get all this detailed information about the method, the results, and so on, because this is already encrypted and protected. So the way to avoid this problem is to use HTTPS. I called it. I didn't have the better name for it. And this is when the pod is starting transaction with HTTP, and the proxy layer is starting HTTPS transaction. So transaction is secure from network point of view, but it's still possible for the Istio to trace these transactions. So you have all those components to the details of the request. And you can see that the duration, for example, is longer. So like in the TCP, it was 69, and Istio HTTPS is 62. So it is really doing the TLS transaction. And with Istio, there is a complexity. So this is also the new namings that you need to find out. And there's an upstream and downstream way of naming convention. So it's like with the river flows from upstream to downstream, and here it's the same. So the client transaction is happening from the upstream to downstream, and here you can also see that the upstream host that is connection happening is on the 2 TCP, and HTTPS is 443. And then from the downstream local address, so the one that the pod tried to initiate in the 3rd column, you can see that the port is 80. So we really wanted to go with HTTP. Istio detected, was able to do a tracing, but then forward to 443, as you can see here, and it was protected with HTTPS. So that's something that I would say you get the money out of the Istio again, yes, because you have a traceability, which is quite nice, especially if you start used to doing that, and it's like almost free. So the story that I told here is that in the beginning, when I started working with Istio, I was not used to checking those logs, and right now this is the first place that I do when there's any problem. So I check, okay, there's a communication problem between this component and that component. It's a little bit difficult to parse it, but with some tools it's quite easy. And it simplifies the troubleshooting. I know exactly when the problem is at the first place. There is so you can realize that these logs is in each microservice. So, okay, that happened. Sorry for that. Where is my mouse? So let me start it again, maybe like that. And with that, I will try to play it again. Have you tried playing it off and on again? Yes. With Istio, it does not work like that, unfortunately. But I will try to. Okay, so let's see if it breaks again. We stop here. Okay, so it's playing. You can see a little bit more into the Kiali console, because the Kiali console is a great view into your service mesh, what is happening. It is a little bit, as you see, again, not maybe super clean, it's not polished interface, but it is really deep into the technicalities. And you can see the problems that are detected, you can see the traffic, you can inspect the traffic, you can inspect the slow traffic. So it is like quite a valuable tool to find out everything what is happening between your services and inside your services. So, and it is quite easy to install. You get it almost out of the box. Yes, this is not something that you will struggle to do. I would say it's a part of Istio, at least that I see it like that. And we said that I lost it. Okay, we said that Istio covers all observability, so it covers the traceability as well. And that is the trace example from Jaeger console. Again, it's something quite out of the box here. The problem with traces is that application needs to tolerate traces between the different requests. But if it pass the headers, HTTP headers of traces, from coming request to the next request, but if it is done correctly, that is the key tool to troubleshoot anything that is happening on your infrastructure. When there's a request that fails, you can find the component that failed this request. You can also see some bottlenecks, performance statistics, all the things related to that in this Jaeger console. So that is also something coming almost out of the box. And that brings a lot of value. It is a very useful tool that it was not existing, to be honest, before Istio or Service Mesh. Such a view into the system, such a detailed view into the system, especially complex big systems. So before we go to the discussion about the metrics itself that Istio provides, I want to talk about the value a little bit and what basically can go wrong. What challenges the SRE face when they have a system or like monitoring system in place. So I asked this question and the answer that I got is like first is delayed incident detection. So it's sometimes very hard to find out that something is happening. So it's difficult to identify the root causes of the issues, even with all the tools that we have right now. That is something that I find very interesting. It's overwhelming amount of dashboards, monitoring, alerts, notifications that we face every day, and they are not helping at all. Lack of visibility for the system performance, or like inconsistent, incomplete data. And the last one here is about the cognitive world. So maybe let me pause here a little bit. So the domain business knowledge that everybody in the team needs to have to be able to troubleshoot efficiently or to find the root cause, that is instead of inside the monitoring system, it is in the requirements for the team to understand all the use cases that are happening and things like that, especially on SRE or DevOps side, that somebody comes to you and like you should be perfectly aware what is the ordering process in your system, what is the checkout and things like that, because you should know about this. So that's a big expectation of this cognitive load during the incident management. And the proposal is to sort it out a little bit, our world, and start to think about the monitoring system in a pyramidal way. So the base of that, what we should have inside the monitoring tools, for me it's end-to-end. You can call it end-to-end, sanity, canary test, something that is from user perspective, checking that system is performing okay, and like what is the process around it, if it is available or not available. So like regular user is doing the checkout, but it is the monitoring that is doing a checkout every 5 minutes, for example. The second layer is the business KPI. So that is maybe a little bit strange for you from the technical point of view that it is mentioned as a second one, but really vital is to know like what is the success ratio of the purchases in our shop. And if it is 80% usually, and right now it is 20, our system is fully ready to support all the requests, but somehow it is 20, that is the problem that we should raise as people responsible for the reliability of the system. So for me, it's the second layer. The third layer is the traffic monitoring. So the Istio is perfectly suited there, and this is exactly what we are right now discussing. So all the requests that are coming to our system, as well as all the requests that are going outside to our system, should be monitored. And if we have it done properly on this layer, it will be simpler for us to go with this troubleshooting, and we will not be overwhelmed with the data. So afterwards, it comes all the other monitorings like application, database, Kubernetes, infrastructure, and there's plenty of monitoring, security monitoring. We can have many of them, but we need to start from the top and really go to the bottom without pushing everything to the SRE. Basically, okay, guys, let's find out what's happening. You have 100 dashboard. Why you cannot find what was the root cause in 10 minutes when we delivered you 100 dashboard? So before and after, it's like the slide that usually needs to be like sales slide. So if you have a big mess, do order it that. So it's easier to said than done, but yes. And then what I propose is that you should really keep it simple. So incoming HTTP traffic on ingress side, that's the key to our system, and we really just need to know what is the total request, 400, 500, what is the latency. In this case, it is 99% of latency, and it is enough, yes? If there's no like all 500s, then most probably our system behaves quite well. What can be quite new is that we should do exactly the same with outgoing traffic. So all outgoing traffic from our network to our other systems, including some databases, should be monitored by us, and we should really pay attention to that. I will talk just in a minute why, and here again, you can keep it simple. Just it is handy to split it to different integrations that you have. If you have integration with some payment system, that it should be like separated on that. So, but let's not overcomplicate the data. You don't need to have everything there, and you don't need to have it too complex to be on that part. And that's again the value of Istio, because every request is routed through request envoy proxy, so you can get the statistics on that out of the box. So why we should monitor outgoing traffic? First is the uptime. So we as SRE are responsible for uptime of our system, but at the same time, if the integrator or the partner system does not meet SLA, who else can raise this as a problem? Yes. So the second is when incident happens, my flow of thinking is like that. I check end-to-end tests. If they are okay, then I would say, okay, that's the other problem. I check incoming requests. Okay, incoming request. I see some problem there, yes, already, like 50% of the request is failing. So next thing I do, I check outgoing request, because I want to know if the problem is on my system or the partner system. If it is partner system, I call to partner. If it is our system, I start troubleshooting. I don't waste time to troubleshoot my system when I should call a partner. If I have it, I can see it. The cost is interesting, because the partner system usually comes with a cost. So if we're making like 10,000 requests a day, that costs something. And suddenly if we start making 100,000 requests, that might be a problem for the business, even if the system is perfectly fine, but we generated the huge cost. And the last one is that if we monitor the outgoing traffic, we can detect the security potential breaches that are in our system. And it's not easy to find other ways, like when we have attacks and things like that. So those four things for me are very critical, that why you should monitor outgoing traffic. And the last part here is how to regain with these metrics, or how to implement those things that I have. I quite struggle. Why? Because I have this 20 years experience. I was developer, architect, I was even product owner, and I get back to SRE after some time, and I struggle why we still do this manual clicking with the Grafana console. Like, well, there's no that many tools to automate that part, or there's almost no tools on this. So it was like for me a little bit shock. Everything is automated except of the Grafana. So Grafana, we need to play with the UI, or we need to play with the JSON. Both are not quite handy. Yes, so this is strange. So I proposed that I just found this one. Maybe there's more. I was really interested in if you have a different experience, I found the Grafanlib. So then you can generate dashboards from Python. Maybe Python is not easy, but then we have tools to do Python better than I do. So you can use artificial intelligence and just ask, okay, please build me a dashboard that shows incoming traffic with Grafanlib, and this is my metrics. You hit enter, you get the dashboard. So it just copy paste and that's it. Yes. Then you can have it in the Python and the code, and that give you a lot of different kinds of values later. So I propose the 10 monitoring as a code, so that you get a version control of what you do. You basically like do it right. You get reusability. So the graph that is getting incoming requests, guys, it's the same as outgoing. We don't need to click 2 times. Yes, so that's what you have. The collaboration of those Python code is much easier than together clicking on the interface. There's an automation, so you can basically have it in the pipeline, Jenkins pipeline, and run it and deploy it automatically. That's not a problem. There's easier to spot errors. I think it's kind of very difficult to spot errors in the dashboards when somebody make a typo and didn't put the correct metrics on that, even though that he think that it was the correct one. And then I don't like clicking, so the clicking is really the one key for me to avoid doing these Grafana dashboards other way. You can reuse this on different environments, so I don't know if it is happening for you that you have only one environment that's the only one that you take care of, or you have like 10 different environments and one is staging, test, dev, QA, end-to-end, and so on. So, and they all require the same kind of monitoring. So you can just use the same, run it 10 times, and that's it. And the last one, that's integration. So you can build your dashboard with the integrations of other systems. So you can get into the database, check something, and then build the dashboard based on this database. So I think it's like the benefits are overwhelming, and I would say for me the Grafanlib or other tool, if I will find it, is the way to go. I don't see any other. And in the fact there is a Istio metrics, so yes, at the end that are coming from Istio. They are not easy as well as other things in Grafana, so I think that's good that we discuss it briefly. So there's a request, Istio request total. So this is all HTTP requests that are traced by your application. If you make HTTPS requests within your pod, it will not be here. So don't look for something that is HTTPS on these metrics. If it was HTTPS, and you didn't use the Istio TLS feature for that, there will be 2 new. It will be connection open and close on the TCP connection. So they are added together, and then you will see all the traffic that is coming through the Istio proxy. And then you have a duration for the HTTP. You don't have the duration for TCP because it's like stream that is open. So you don't only see the stream that was open. So you don't see anything like how it was happening. And you have this bucket count sum. So you can make histograms, you can make percentiles, you can make average of that. If you use a sum and then divide it by count, and you have an average. So you can really play with that. It's like standard way of doing that. And then you can have also bytes going from and to your application. So that's on both sides, TPS and TCP. It's quite good to count them and then see what kind of traffic that we have. If we see with traceability like 10% of the traffic that is going together, or it is like more like 50, and you should aim to have everything traced and very little on the plain TCP, which you don't basically know what it is. It can be a hacker, it can be application, it can be only errors. You don't have clue what is behind. But you just have information about the connections open, closed, and if there will be connection asset, it will be the information will be on this first statistics Istio TCP connection closed that will have this error inside. Oh, sorry for that. And the Istio labels are something that is quite nice. I think it's Istio way, yes. So they cannot have two labels. They need to have 100 labels, so you can use 100 different labels. And there's a different versatility, so you can do everything you want. There's a different naming, so you can use workload, service, pod, application. There's an errors that you can filter on. So there's you can even add your custom tags if you want. So and you can configure that to have more of them or less of them if with Kubernetes objects in the way that you grab them from the Istio. So that's like a real variability and all the possibilities of the world that are in these Istio labels. With this all variability, you might hit the problem of Prometheus memory, because each series that is created consumes some memory. And if you have a 100 pod, and then every of those pods can easily 100 labels, but it can also do like 1,000 labels if you configure a little bit different, because there's a lot that you can get. And then after each deployment, every new pod will be restarted. So you'll create a new metrics and new metrics and new metrics. You do three deployments, and then your Prometheus needs to have like 10 gigabytes of memory to basically store of that. You can read about those problems in those two places, but if you hit it, think about reducing these labels on the Istio side. So I hope that you like it, and I just wanted that you remember those three things from my presentation, and maybe you can get back to it later. So first is less is more. Don't put every metric that you have onto the dashboard. Think about your dashboard. Maybe most of them needs to be deleted. And think about SL journey or your journey in mind. So if you think that in my application, will do the troubleshooting in these 4 steps, make sure that those 4 steps are in the center of your monitoring, not the other way around. And invest upfront. So here, I mainly think about first learning about Istio, and second building on top of Istio the tools or the ways, the processes that will help you achieve your basic objectives. So SRE and reliability, troubleshooting, incident management, and all of that. And to use Istio to pay your bills, to have your hand risen when the second question is if you enjoy Istio, you need to learn this technology. And learning curve is not easy. It's not simple technology, but it's definitely to be done. And I would recommend you spend some time on this learning side, and just don't discourage yourself. Yes, and you will enjoy it later. And I think that's it. So thank you. You can find me first of all in Idemia, and then on LinkedIn or Medium if you want to read about what I do or play. So maybe do you have any questions?